Okay, Assalamualaikum class. So today we'll be going into chapter 7 and that will be animation. Okay, so what exactly is an animation? Animation is defined as the act of making something static comes alive. So basically when we have just a still image, it's just a graphic. So when the graphic is moving or you see it is as if it is, alive, it is an animated image. Okay, something that is static is just plain graphic. If the image is moving, then we call it an animation. Okay, so usually animation is concerned with the visual or aesthetic aspect of the project. Basically, it is what we see in our project. Okay, something that is moving into and across the screen, so it deals with the visual aspects of the project. Okay, so animation is actually an object moving across or into or out of the screen. So if you suddenly see on your screen, you have something coming inside, something going outside, something going across your screen. Okay, anything that is moving about in your screen is known as animation. Okay. Alright, so when it comes to animation, you can either animate the whole project or you can animate some part of the project. If you animate the whole project, then it can become a video. Okay, for example, you have Upin Ipin, you have SpongeBob SquarePants, okay, where those are animations, where the cartoons are drawn and are created as animations, which in the end, since the animation is drawn from is drawn and is moving from the beginning until the end, so that is known as animating the whole project. So we call that an animation video. All right, or you can animate some part of the project. Let's say a certain area of your project you want to do animation where things going inside and outside, then you can also do that. Okay. Visual effects and transitions are available inside most multimedia authoring tools to allow us to animate objects. For example, if we take a look at PowerPoint, okay, Microsoft PowerPoint, you have visual effects or transitions such as fades, okay, zooms, you have wipes, okay, you even have dissolve. So all of these things are known as transition or visual effects, where if it's just still, it is just a plain text, but since it's moving, okay, we call it as transitions. Okay. All right. So how does animation works? Okay, it all depends on the principles of animation. Okay, animation is possible because of a biological phenomenon called persistence of vision and also psychological phenomenon called phi. Okay, how it works is that it says here an object seen by the eye is chemically mapped on the eye's retina for a brief time after viewing. So it's like this. Let's say I want to create an animation where I am waving. Okay, if it's an image, okay, the image is still, right? An animation is something that is moving. Okay, how animation works is that let's say I want to move my hand from here until here. Okay, so what I'm going to do is I'm going to create pictures, okay, starting from this first movement and then gradually moving until I reach my final position. So when I play this movement really fast, okay, that is how I create my animation. Okay, the technique here is there are a lot of images. Okay, when it comes to animation, the technique here is you have a lot of images. So when these images are played very, very fast, okay, it will create illusion of movement. Okay, you will see as if that thing is moving. All right, so how do our eyes see it as animation? Okay, it's because of persistence of vision. It is the it is how our eye works. Okay, so our eyes usually see images. So when we see things, our brain catches it. Okay, so when the thing is moving very fast, our eye is trying to catch the images that we see. Okay, each one of them. Okay, but if it is moving very fast, okay, our eye couldn't really catch what it sees, so that's why it kind of sees it as if it's blended together. Okay, so when a series of images are changed very slightly and very rapidly, meaning very fast, the human mind will perceive them as if they are seemingly blended together, where we see it as an illusion of movement. Okay, so they are separate images, but when we play it very fast, so our eye couldn't really catch it, so that's how we see it as if it is moving. Okay, so that's what we call principles of animation. So we have persistence of vision and also phi. Okay, due to phi, all right, which is a psychological, which is our brain kind of sees that as if it is moving because our eye couldn't really catch it very fast. Okay, although it is mapped onto our retina. All right. Okay, so animation, okay, like I've said, is a series of images that are rapidly changed to create an illusion of movement. Okay, so when we talk about an animation, okay, how do we create an animation? The animators will draw or create the images one by one, and it will be played very, very fast to create that illusion of movement. All right. So when we create animation by computers or using computers, okay, there are three types of animation that we can do. We can do a 2D animation, 2.5D animation, and a 3D animation. Okay, so let's go into a 2D animation. All right, 2D animation is created in a 2D space, whereby it will produce a flat image that has movement and is represented in terms of width and height on the screen. Okay, when we talk about 2D animation, you will see that most often the cartoon that were created as a 2D animation, it is very flat. Okay, for example, you have here Snow White. Okay, the cartoon that was created, the animators draw it by hand. All right, they will draw each character by hand. All right, and basically the images is drawn within the x-axis and the y-axis, so it's very flat. It's in a flat image. Okay, so if you want to create that animation, there needs to be a lot of pictures, slightly different one after another. Okay, so it requires one image to be followed by another in a slightly different position and so on in order to create movement. So everything must be drawn. Okay, so every single movement, let's say I want to wave my hand, so each of the movement that I do, I need to draw it. Okay, so when I play it very fast, then it will be creating an illusion of movement. All right, so what's a 2.5D space? All right, 2.5D animation. So 2.5D animation is not a 3D animation. If you take a look at this example right here, this is a movie called Feast. Okay, it looks as if it is 3D, right? But actually it is not. In fact, 2.5D animation is actually flat. All right, it is kind of like a 2D animation. But why do we see this animation as if it is 3D? It's because there is an illusion of depth. Okay, so how do we create that depth, illusion of depth? We're using shadowing and highlighting. Okay, so whenever we draw something flat, in order for us to make it look as if it's, you know, real, okay, we add some shadows and we add some highlight, and that is why we can kind of see it as if it is popping up or if it is 3D. Actually, it is not. All right, so the next type of animation is called a 3D animation. So a 3D animation is created in a 3D space. So where we see 3D animations such as Minions, you have Inside Out, and most cartoons nowadays, you will find that they are all in 3D. Why? Because they seem to be more realistic and lifelike. All right, so when we have 3D animation, it creates a more realistic and lifelike objects that will be placed on a virtual RAM represented in all 3 dimensions. So with a flat animation, it is only X and Y's. Okay, with a 3D animation, we have X, Y, and also Z, which is the depth. Okay, so that's why the animation will look as if we can see it in all directions or in all angles and directions. Okay, so the model of characters' objects can simply be moved and dragged along the screen from all angles to create movement. Now, how we create 2D animation and 3D animation are completely different. Okay, with 2D animation, since it is a flat image, what we're doing is we're drawing the image. We're drawing each movement for that animation. Okay, so if I want to move my hand like this, I need to draw each of my hand in what position that it may be. Okay, but with 3D animation, we're not drawing it. Okay, we're creating models. Okay, so let's say I'm a model inside that scene. Okay, so if I want to create a movement where I move my hand, all I need to do, since I have created this model, okay, I can just easily take my hand and just move it along. Okay, with 2D animation you have to draw it. With 3D animation you don't have to draw it. Okay, you can just move the object, okay, along the scene, okay, if you want. So while you're moving it, it's going to take pictures of your model. Okay, that's how we create that animation or create that movement. Okay, so different is 2D we draw it, 3D we use models. Alright, so that's the difference between 2D and 3D animation. Alright, so when we create an animation, okay, these are a few things that you need to consider. Alright, so first of all, you need to create a written script that includes all the activities and the required objects to be placed inside the animation. Okay, since an animation requires movement, okay, let's say I'm trying to create a cartoon of myself, okay, what I need to do is I need to create a written script. Why I need to have a written script? Because when you create an animation, you're creating movement, right? So whenever I speak, the words that I speak will be different according to my lines. All right, so that's why it's important for you to have a written script. Okay. Okay. Also, you can create a storyboard to visualize the animation. Okay, so for each scene you might consider what kind of movement that you want to do. Maybe I want to wave my hand or both of my hand. Okay, so if you plan out your movement, it is easier for you to do your animation. Okay, next thing is for you to choose the animation tool that best suited your animation. Okay, so whether you want to use Adobe Animate, or you want to use Macromedia Flash, or you want to use a 3D software, okay, whatever tool you may be, it will depend on the type of animation that you want to do. Okay, then once you have chosen your tool, okay, you can build and tweak the animation sequences. For example, you create your objects and plan the objects movement. So within your tool, okay, within your software, you can create your objects, okay, whatever it is inside your animation, okay, and then you can create the movement of the objects that you have created. Okay, and then lastly, once you have done all of your animation, the movement, the objects, everything like that, you can post-process your animation. Okay, you can add sound. Okay, let's say if I clap my hand, then I can maybe add some sound effect of clap. Okay, then if you've done that, then we can just render your animation. Okay, then you have a final animation product. All right. Okay, so let's go into animation techniques. Okay, how we can create animation using different techniques. So the first technique that I'm going into is called cell animation. Okay, cell animation is an animation technique that have been made famous by Disney. Okay, as we all know, Disney is a movie company, a cartoon or animated movie. All right, so this technique is made famous by them. Okay, for example, Snow White. Okay, it uses cell animation technique to create their movie. Okay, so it uses a series of progressively different graphics, also known as cells, on each frame of movie film. Okay, you will notice that I will show you a video after this. Okay, which is a video on how Snow White is created using cell animation. Okay, so how it works is that each animation uses this clear celluloid sheet. This is known as cell. Okay, where you have like this plastic, clear plastic. So on this clear plastic, you will draw your animation on that. So each movement that you do, you will draw it on that clear plastic. Okay, so to make movies on films, the animation is shot at 24 frames per second, meaning that in order for them to create 1 second of animation, they need to draw 24 frames of that cell. Okay, meaning that they will have 24 different cells in order to create only 1 second of animation. Okay, so imagine if there is a minute of animation. Okay, Disney may require 1,440 separate frames, and each frame is composed of many layers of cells. Okay, so meaning that if I want to move my hand like this, maybe this is a few seconds, so each of these movements that I do will be drawn on that clear plastic sheet. Okay, and it will have layers as well. Layers meaning that each object, or let's say I have myself as one object, it will place on one cell. Okay, the background may be another cell which is at the back. Maybe I have another character, so that can be placed on that layers as well. Okay, so that's how cell animation works.
Remember as a kid how you made your own movies by drawing little figures on the pages of a pad and flipping the pages to make the figures move? That's the basic principle behind animated pictures today. But that's not all there is to it. First, you need a story. Thinking up funny stories is the job of Walt Disney's writers, gag men, and sketch artists. After much trial and error, several hundred rough drawings illustrating the high points of each story are completed. Let's follow the story into conference, where Walt Disney and his hard-boiled directors look it over. Not a picture, long or short, goes into production without Walt's personal okay. Next, a director whips the script and dialogue into final form. Then he calls in his assistants, including his musical composer, and plans the score of the picture, timing out each scene carefully. He even acts out every move of the action, so that the men who work with him can visualize what the scene will look like on the screen. Now he sets his expert animators to work, the skilled artists who draw every movement in complete detail, just as you will see it in the theater. Each animator's drawing board is lighted from below. He looks through the paper at the character he has previously outlined and draws the next movement in correct position. This clever animator is using a mirror to capture a tricky facial expression like this. Let's move along to the test camera department. Here the animator's rough drawings are photographed in sequence, one at a time. This film is developed and returned to the animator, who checks to see how good it is by running it in a small projection machine called a moviola. In this moviola, as the animator runs his film backward and forward, we catch a graceful glimpse of the screen's newest heroine, Snow White herself. Now we're in one of the studio projection rooms, where Walt and his staff study the rough animation of a sequence about the 7 lovable little dwarfs. Once they are okayed, the thousands of pencil drawings go to the inking department. Here, hundreds of pretty girls, in a comfortable building all their own, well lighted, air-conditioned throughout, cover the drawings with sheets of transparent celluloids. Then they painstakingly trace every line of every drawing in ink, following exactly in every detail the original animation drawings. Now the picture moves into its final stage, color. In the studio paint laboratory, all colors used are made up from secret formulas. Expert chemists develop more than 1,500 different shades of color for Snow White and the 7 Dwarfs. The inked celluloids next go to the painting department, where more pretty girls apply the final colors on the back. Snow White and the 7 Dwarfs required 250,000 celluloids painted like this one. In another department of the big Disney studio, artists delicately paint the beautiful stage settings for the picture. These backgrounds are done in watercolor. Artists work for months on backgrounds like the interior of the 7 Dwarfs cottage. But the colossal task isn't finished even yet. The celluloids and backgrounds must still be photographed by the master camera in Technicolor. Here the operator puts a Donald Duck celluloid on top of a background as the overhead camera exposes one frame of film. To photograph Snow White and the 7 Dwarfs, this operation had to be repeated more than 500,000 times. Next, the film passes into the hands of technicians, and the sound effects are recorded. Finally, a symphony orchestra records the musical score, the hit tunes that will thrill listeners the world over. Now comes a crucial moment, the picture's world premiere in Hollywood. Crowds flock to see an animation exhibit set up outside the theater.
Okay, so let's go into frames per second. When we have animation, we need to talk about frames per second. Okay, the lower the frames per second, the less smooth your animation will be. The higher the frames per second, within the animation, the higher your frame, the higher the quality of your animation. Okay, why did I say less frame will produce less quality? Because let's say in 1 second you have 10 frames. Okay, in 1 second you have 10 frames, so 10 frames per second, meaning that to create that animation for that 1 second you have 10 pictures. Let's say here, 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 let's say. Okay, so it will create the animation based on the objects that was placed. So when it is played very fast, you can kind of see the objects at different areas. Okay, but if you shoot your animation at 30 frames per second, okay, you will notice that at 10 frames per second there are empty spaces, right? Because there isn't much image. But when you have 30 frames per second, meaning that there are a lot of image that are used to create that 1 second of animation. So there will be images in between each frame, so creating that 1 second of animation. Since there are a lot of images, the movement of your object will be a lot smoother. Okay, so that's why higher frames per second will create a smoother movement, whereas lower frames per second will create a less smooth movement. All right. Okay. Now, how cell animation works? Okay. Like I've said, when we create an animation, we need lots of pictures, right? Okay. Let's say I want to create this movement. Okay. So how I create this particular animation, I need to begin with a keyframe. Okay, keyframe is actually the first and last frame of an action. So if I want to do this, my first frame is this. So this is my first keyframe. Okay, what is my last movement? This. Okay, I want to go from here to here. So this is my first keyframe. This is my second keyframe. Okay. So in between, in order for me to create this movement, in between these two keyframes, okay, this is known as tweening. Okay, tweening is the series of frames in between that keyframe to create that movement. Okay, since I'm doing this, okay, each of this frame is known as tweening. Okay, the first movement is called keyframe, this last movement is called keyframe. In between the two keyframes, you will have your tweening. Okay, so when you flip through the image very fast, or when you play that image very fast, then it will create that illusion of movement. Okay, so this need to test out their animation whether it's smooth or not. Okay, they will do a pencil test whereby they will flip through the frames. It is as if you're flipping through a book. You know where you have a book, and then at the edge of a book you would draw different pictures. So when you play it very fast, you can kind of see the pictures is moving, right? What you're creating is actually an animation. Okay, it is a similar concept to this as well. Okay, so now let's talk about computer generated animation. Okay, so animation can either be created by hand, where we have cell animations where everything is drawn by hand. Nowadays we don't really do that because it is too time consuming. Okay, each picture must be drawn by hand, must be colored by hand, so we don't need that since we have computers. Okay, so animation that is created using a computer is called the computer generated animation. So the concept of computer animation is very similar to cell animation, where it uses the same concept of layers, keyframes, and also tweening. Okay, a quick recap. Okay, keyframe is the first and last action. Okay, tweening is the frames in between to create that action. Okay, layers is if we have many objects within that one scene. Okay, so you can have layers of objects. All right, so now the main difference between a cell animation and computer animation, it is in how much must be drawn by the animator and how much is automatically generated by the software. So if we do a cell animation, since it's a traditional method, the tweening, what we do is we have to draw each movement in between the keyframes. You must draw each one. But when we use software inside your computer, your animation, okay, how it works is that you need to create keyframes. Let's say this is my first keyframe, this is my last keyframe. In between is called tweening, right? Okay, with software like Flash, you don't need to draw the frames in between the keyframes. because the software can actually automatically create the tweening for you. Okay, so that's what it means by automatically generated by the software. So it's a lot easier. You don't need to draw each frame one by one. All right. Okay, so the next type of animation technique is called kinematics. All right, kinematics is a study of movement and motion of structures that has joints. Okay, so we usually relate this with 3D animation. Okay, so when we have a model, okay, such as a man right here, so whenever we have a model of a human, we need to know how to move its joints. Okay, so let's say if I want to move my hand, okay, how do I move? Like I have my wrist. Okay, if I move my finger, can I bend my finger to the back, way back? Is that logic? Is that logical to do that? Okay, so the joints must be connected together, and you must know how to create that movement without it looking weird. All right. So for example, a walking man. So to animate a walking man, you need to calculate the position, where you're going to place the hand, for example. How are you going to rotate the wrist, for example? How fast, the velocity or acceleration of the joints you want to move. Okay, so this is all the things that you need to study when it comes to creating movement for your objects. All right. Inverse kinematics is the process where you would link objects, define their relationships and limits, and once relationships and parameters have been set, the computer will calculate the result. Now, like I've said, with kinematics, you are studying the movement and you are creating each position, the rotation, you are determining it yourself. Okay, whereas in inverse kinematics, you just need to rely on the relationships and limits of your object. For example, I have my hand right here. Okay, so I have my wrist and I have my forearm and I have my fingers. All right, so if I want to move my hand, I want to do this. Okay, so if I just pull my hand like this, okay, automatically everything will be followed. Okay, because you already created that relationship and limits. So if I want to move my hand to the back, I can't do that. Okay, because I've created that limit where I cannot do that. So this is known as inverse kinematics. So the movement can be created depending on the relationships and limits that you have set on your joints. Okay. Alright, the next type of animation technique is called morphing. Alright, morphing is an effect where one image will seamlessly transform into another. So meaning that you will have different images. So from these different images, okay, you can somehow blend them together as if they are transforming from one thing to another. Okay, very seamlessly. Okay, so to create a smooth transition between two images using morphing, okay, you need to properly set the key points where the points in the start image should move to the corresponding point in the end image. Meaning that, let's say I have this image where I have my face, okay, and then I want to morph it into a face of another person. Okay, what I need to do is I need to create points. Maybe this is the point for my eyes, point for my nose, point for my mouth, etc. So when I try to move and try to change the shape from this shape to a different shape, you can easily do that and morph it because you have the points ready. Okay, so it will somehow blend and morph into another shape. Okay, that is known as morphing. Alright, so animation file formats. Some of the formats used to store animation will depend on the software that you use. So if you use Adobe Animate or Adobe Flash, the file is .fla, .swf. Okay, but if you use an Adobe Director, okay, the file is .dir, .dcr. So if you use Animator Pro, .fli, .flc. If you use 3D Studio Max file, it's .max. Okay, but if you're trying to create a vector of animation of vectors, then it is .svg. Okay, like I said, if you actually render your animation as a whole, okay, you can create a video file. Okay, so animation can be rendered into a digital video file which can be played using media players. So it has now become a video. So since a video, you have things like AVI, you have .mov, you have .mpeg. Okay, so those are all formats for videos. Okay, so another type of file formats for animation is called GIF or GIF, whatever you want to call it. All right. So a GIF or GIF is created by using multiple images. So you have these multiple images that you actually put into a single file. Usually you will find a GIF inside your browser. You have Tumblr where you have GIF. Okay, even your social media you have GIFs. Even Facebook you have GIFs. Okay, so how they are created, they are you guys can actually create this yourself, okay, by taking different images and then you play it very fast, okay, then it will create an animation. Okay, so to create GIF you can use applications like Stone Design's GIF Fun or ULED's GIF Animator. Okay, so you can definitely try that yourself. Alright, so this is some tips when doing animation. Okay, when doing animation, you should use it carefully and sparingly to achieve the greatest impact. So when you have animation, do not use too much of it. Imagine if I want to do a presentation, okay, and inside that presentation, I have lots of animation. I put it there. So since everything is moving, your eyes don't know where to look. Okay, so that's when it is not good when you use too much of it. All right. And nowadays, the most commonly used tool to create animation for Windows, Macintosh, and web is Adobe Flash or Adobe Animate. Okay, if you notice that nowadays the most popular tool to create animation is actually Adobe Flash or Adobe Animate. Why? Because it can create a Flash file. .fla, okay, I mean the rendered animation file is .swf. So this .swf animation file can be placed on your website or your web page. Okay, so a browser can easily play that file if they have plugins. Okay, so that's why animation using Adobe Flash or Adobe Animate is popular, right? Okay, so to create animation, there are a few techniques that can be used inside Adobe Flash. Okay, so the first type of animation we have is frame by frame animation. How it works is that animator will draw on the scene one frame at a time with slight differences in between each individual frame. So if we create a frame by frame animation, what we're doing is, okay, instead of creating keyframes and you tween it, okay, you create, let's say I want to do this, okay, I want to wave my hand. Instead of you creating keyframe and then another keyframe and you tween, okay, with frame by frame animation, you're not creating keyframe. Every single one is a frame. So you're creating frames. So since you have a lot of pictures, okay, you can play it very fast, so that will create a movement. Okay, so that is frame by frame animation. The next type of animation is called the tweening animation. Okay, so tweening animation, the animator only needs to draw the starting and ending frames, as the software will automatically generate the frames in between. Okay, this is what I mean. Okay, with tweening animation, you only need to draw the first keyframe and the last keyframe. So the frames in between is called tweening. Okay, this tweening can be, when you create the tween, okay, the software will automatically draw the frames for you. Okay, so this is known as tweening animation. Okay, there are a few tweening tools that you can use, which is motion tween. Okay, so you can use motion tween to move or rotate or change color or size of object. Let's say you want to create let's say you want to move from one place to another. Let's say I have a ball and I want to move from this place to another place. This is called the motion tween, whereby you only need to draw the ball at this location and then keyframe another location. So in between, the animation, the software will automatically create that tween for you. Okay, and then you have motion tween along a path, whereby you have object. Okay, so you draw like a path, crazy different paths, so the object can actually move according to the path that you drew. This is known as motion tween along a path. Okay, so the next type of tweening is called the shape tween, where you can morph shapes of object, meaning that let's say I draw a square, then I want to create a morph. Okay, I want the square to morph from a square to a circle, for example. So suddenly from square it will morph into a circle. Okay, this is known as a shape tween. All right. Another technique is called easing. Okay, easing is a tool to manipulate the acceleration effects placed on an object. Meaning that, okay, let's say you want to draw a bouncing ball. Okay, as we all know, in order to create a very realistic bouncing ball, okay, you will have gravities and velocities and acceleration. Okay, so you can actually manipulate how fast your object is moving for your animation. This is known as easing. Okay. Alright, so this is just some examples on how you can create your animation or how you can draw your animation. So let's say you want to draw a rolling ball, okay? So what you can do is, okay, in order to create an illusion of that ball is rolling, you can actually change the position of the ball going from one position to another position. So it will look as if it is rolling when you play it very fast, okay? And next example is a bouncing ball. Okay, so when you do a bouncing ball animation, like I said, you have gravity. Okay, since you have gravity, of course the acceleration will be different when it goes up and when it goes down. Okay, so as it goes up, the speed will get a lot slower. When it goes down, it will get a lot faster. Okay, so that is bouncing ball, so you can use easing for that. All right. Okay, when it comes to animation, like I've said, you have layers, right? Okay, so layers is important when you have different objects inside your scene. Let's say inside this scene, I have a dinosaur and also I have another object, which is the man. And I have another layer, which is the background. Okay, so in order for me to create an animation scene whereby a dinosaur is chasing a man, okay, I will place the layer of a dinosaur on top of that background, and I will place that man object on top of that background, okay, when I can create that scene. Okay, so again, each object will also have their own movement. So the man will be running, whereas the T-Rex or the dinosaur will be walking along the bridge. Okay, and you will notice that on this bridge, it looks as if it has been cut out. Why is that? Because since you want to create a more realistic animation, okay, since you want to make the dinosaur and the man as if it's walking on the bridge, okay, we can cut the part where the front part of the bridge, okay, so it is in front of the object instead of the object being in front of the bridge. You know what I mean? Okay, so that is layers. So you can always take your layers up and down depending on which one you want to put it on top. Okay, so again, when it comes to animated scenes, you will have layers for each object. Okay, all right, so that is the end of this chapter. So I will see you guys in our next chapter. Bye, class.